Today we are going to be talking about triangles. My name is Michelle and I will be your narrator, and Becca will be drawing on the whiteboard for us. We know that the Pythagorean theorem works for all types of right triangles, but what about the acute and obtuse triangles? Using this chart that we created in class, we can look at all the different types of acute and obtuse triangles. First, let us look at the acute triangles. We have prepared for you an example of an acute scalene, acute isosceles, and acute equilateral triangle. We will start with the acute scalene triangle. This triangle has angle measurements of 40, 60, and 80 degrees, and sides of 4.25, 5.75, and 6.5 inches. Remember that the two shorter sides represent a squared and b squared, and that the longest side represents c squared. We have set up the equation a squared plus b squared equals c squared, and we'll solve this equation using algebra. By doing so, we have come to the conclusion that for this acute scalene triangle, a squared plus b squared is greater than c squared. Let's see this same method with an acute isosceles triangle. This acute isosceles triangle has angle measurements of 50, 50, and 80 degrees, and side lengths of 4, 4, and 5.1 inches. Side A and B are both 4 inches, and side C is 5.1 inches. After solving this equation, we know that 32 is greater than 26.01. So, we know that a squared plus b squared is greater than c squared. Will our final acute triangle also follow this pattern? Here's an acute equilateral triangle with 3 angle measurements of 60 degrees and 3 side lengths of 5 inches. Since this triangle is equilateral, a squared, b squared, and c squared are the same numbers. We can see that a squared plus b squared is greater than c squared in this case as well. Looks like we do have a pattern. For every acute triangle we tried, a squared plus b squared was always greater than c squared. Now let us look at obtuse triangles. We've prepared for you an example of an obtuse scalene and an obtuse isosceles triangle, since we already know that an obtuse equilateral triangle does not exist. We will start with the obtuse scalene triangle. This triangle has angle measurements of 20, 50, and 110 degrees, and side lengths of 2.4, 5.7, and 6.9 inches. Again, in order to come to a conclusion, we must set up the equation a squared plus b squared equals c squared, and solve this equation using algebra. .25 is not greater than 47.61. Therefore, a squared plus b squared is less than c squared for this obtuse scalene triangle. Now how about the other obtuse triangle? For this obtuse isosceles triangle, its angle measurements are 30, 30, and 120 degrees, and its side lengths are 4, 4, and 7 inches. Using our equation, we've realized that 32 is not greater than 49. Therefore, a squared plus b squared is less than c squared. Looks like we have a pattern for obtuse triangles. For every obtuse triangle we tried, a squared plus b squared was less than c squared. We already know that the Pythagorean theorem works for right triangles. From our examples, we can conclude that for every acute triangle, the sum of the squares of the two shorter sides is greater than the square of the longer side. For every obtuse triangle, the sum of the squares of the two shorter sides is less than the square of the longer side.